Hello! Yes, and welcome to our first set of notes for Unit 4, Objective 4.1, Factoring Quadratic Expressions. Today, we're going to factor quadratic expressions, but before we get into that, we're going to review how to factor by grouping. This is going to be an important process that we can use while factoring quadratic expressions. Now, factoring by grouping can occur when we have an even number of terms. So if you look at the sample problem, we have 4 terms here. And I'm sure this is probably familiar, which is why I just want to touch on it. We'll go through it, do a couple examples here. The first thing we're going to do is split the polynomial into 2 binomials. So we're going to say, okay, 4p to the third plus 8p squared and 3p plus 6. Those are going to be the 2 things we look at. We're going to factor the GCF out of the binomials. So this first binomial, I can take out 4p squared. When I do that, I'm left with p plus 2. And then we're also going to factor out of the second binomial a GCF, which in this case would be 3. And when I do that, I'm left with p plus 2. Lastly, we're going to combine the outside terms, the terms that we factored out, together into a binomial. So we'll have 4p squared plus 3 times p plus 2. And that is the factoring by grouping process. Notice, if we were to multiply this back out, I'd get 4p squared times p, that's 4p to the third. I get 4p squared times 2, that's 8p squared. 3p, 3 times 2 is 6. So I would get that original statement. Remember, that's what factors are. They're a way to see what was multiplied together to get these statements. Very good. So that's how factoring by grouping works. Let's go through it a couple more times here. So if I'm looking here, I have 16n to the third plus 20n squared. Let's try to factor that out. So 16, 20, I can take 4n squared out of that. When I do that, I'm left with 4n plus 5. Now looking at negative 28n minus 35, and factor out a negative 7 there. When I do that, I'm left with 4n plus 5. Now, the key to factoring by grouping is that these 2 terms in the parentheses are the same. Because if they are, that's what allows us to combine the outside terms, 4n squared minus 7, which gives us our factored form of 4n squared minus 7 times 4n plus 5. Now, look here. This is a unique example for letter B. 6n to the third minus n squared, 9n minus 3. My GCF in this first one would be just n squared. So I'd get 6n minus 1. Now, out of my second, my GCF is 3. But when I factor that out, I get 3n minus 1. So notice, these 2 things here, 6n minus 1, 3n minus 1, they are not the same. There's nothing else I can factor out to make them the same either. If they are not the same, then this isn't factorable, and we would call this prime. All right? If something is prime, obviously it's not factorable. It's only factorable by 1 in itself. Think about our numbers, our prime numbers. 7, just 1 and 7 are the factors. All right, so now that we've gone through that, let's look at factoring quadratics. So there's really 2 different approaches, and it depends on the type of equation we're given it. So we're going to start with factoring quadratics when a equals 1. That means the leading coefficient here is 1, or really, more aptly, it doesn't look to be a leading coefficient. So what we want to do is we want to find 2 numbers that add up to b and multiply to c. And those are going to be the values of our binomial factors, the constants in our binomial factors. So if we look at letter A here, x squared plus 6x plus 8, I want to find 2 numbers that add to 6 and multiply to 8. So we'd say b equals 6, c equals 8. Those numbers, of course, are 2 and 4. 2 plus 4 is 6, 2 times 4 is 8. So my factors here would be x plus 2 times x plus 4. And that would be x squared plus 6x plus 8 in factored form. Now at b, negative 7, c, 12, I'm looking for 2 numbers that multiply to 12 and add to negative 7. Those would be negative 3 and negative 4. Negative 3 plus negative 4 is negative 7. Negative 3 times negative 4 is 12. So my factors here would be x minus 3, x minus 4. X squared minus 14x plus 49, letter C. Well, B is negative 14, C is 49. Those two numbers would be negative 7 and negative 7, right? Negative 7 plus negative 7 gives me negative 14. Negative 7 plus negative 7 gives me positive 49. So I would have x minus 7 times x minus 7. You could also write this as x minus 7 squared. That's what it means to be squared, to multiply something by itself. So there we go. All right. X squared minus x minus 42. This one's a little more tricky because we need something that adds to negative 1 and multiplies to negative 42. So after thinking about it, hopefully we can realize that those numbers are negative 7 and positive 6. Negative 7 plus 6 is negative 1. Negative 7 times 6 is negative 42. So we'll have x minus 7 times x plus 6. X squared minus 36. So this is a unique one where if you want, you could write x squared plus 0x minus 36. So you get that b value. B equals 0, c equals negative 36. Anytime we don't have a b value, we're probably dealing with, well, we will be dealing with two numbers that have the same absolute value, one positive, one negative. So in this case, it would be positive 6 and negative 6. All right, because 6 times negative 6 gives me that negative 36 I need, but 6 plus negative 6 gives me the 0 I need. So my factors for this one would be x plus 6 times x minus 6. And lastly, looking at letter F, x squared plus 4x minus 32. My b is 4, my c is negative 32. So I need two numbers that multiply to negative 32, add to 4. Those would be positive 8, negative 4. 8 plus negative 4 is 4. 8 times negative 4 is negative 32. X plus 8 times x minus 4. And that's the process, kind of the mental exercise we need to go through when we're factoring quadratic trinomials with a leading coefficient of 1. Now, what if the leading coefficient is not 1? What if we do, in fact, have a value for a? For example, in this sample problem here, 5x squared plus 11x plus 2. Well, there are lots of ways to factor this. What I recommend is called the AC method. So here we're going to break down the steps of the AC method. First thing, check to see if we can factor out a GCF. Now, looking here, I have 5, 11, 2, nothing I can factor out of all three of those. So what we're going to do is we're going to multiply together a times c. So think here, if we look at our values, a is 5, b is 11, c is 2. So if I multiply together a times c, that would be 5 times 2, and that gives me 10. So what I want to do is find two numbers that have a product of a times c and a sum of b. So I need two numbers that multiply to 10 and add to 11. Those numbers, of course, would be 10 and 1. So what we're going to do is we're going to rewrite b, 11x, as the sum of two values added together using these numbers. 10 plus 1 is 11. So I'll say 5x squared plus 10x plus 1x plus 2. Notice, this is the same value as our original, right? These two equations have the same value. They're just written a little differently. But notice how many terms I have now. 4. How do we factor with something with 4 terms? By grouping. So 5x squared plus 10x is my first binomial. X plus 2 is my second. I can take out 5x here. I'm left with x plus 2. Now there's nothing to take out here, but remember we can always factor out 1. And that gives me the x plus 2 I need. Remember, these two need to be the same, the two values inside the parentheses. And when they are, that allows us to say 5x plus 1 times x plus 2. And that is how we would factor using the AC method. Let's do a couple more examples, make sure we understand here. This first one's just kind of a fill-in-the-blank process. So the first thing, 2x squared plus 13x plus 6. There's no GCF, so the first thing, a times c is 12. So I'm looking at factors of 12 that add up to b, 13. That would be 12 and 1. So I rewrite b, 12x plus 1x, and then I do my GCF factoring here, my factor by grouping. So I can take 2x out, so I'm left with x plus 6. I can take 1 out to leave me with x plus 6. So my factors here are 2x plus 1 times x plus 6. So that is it kind of still being helped, kind of still filling in the blank. Let's try to do it on our own here. So this first one, 5x squared plus 19x minus 4. No GCF, so I start by multiplying 5 times negative 4. That gives me negative 20. So I need numbers that multiply to negative 20 and add to 19. Hopefully we caught those pretty easily. That would be obviously 20 and negative 1. 20 times negative 1 gives me negative 20. 20 plus negative 1 gives me the 19. So we'll rewrite here 5x squared plus 20x minus x minus 4. Factor by grouping. 5x squared plus 20x, that gives me 5x times x plus 4. Now I need to factor something out here to give me x plus 4. If I take out negative 1, that would give me x plus 4. So my value here would be 5x minus 1 times x plus 4. Voila. Mwah. Well done. All right. Looking at B, ooh, this time I do have a GCF, don't I? So I'm going to start by factoring that 2 out. So I'll have 2 times 4w squared minus 5w minus 6. All right, so now I can use these smaller numbers. So I'll say A is 4, B is negative 5, C is negative 6. So A times C is negative 24. So two numbers that multiply to negative 24 add to negative 5. It's okay to think and to not be able to recall those right off the top of your head, you know. This is what makes factoring difficult, having that number sense. So these two numbers in this case would be negative 8, positive 3, right? Because negative 8 plus 3 gives me negative 5. Negative 8 times 3 gives me negative 24. So those are the numbers I'm going to use to rewrite B. So I'll say 4w squared. Again, I'm pulling from our factored form. Minus 8w plus 3w. Oh, getting ahead of myself. Plus 3w and then minus 6. Factor by grouping. 4w I can factor out here. I'd be left with w minus 2. I can factor out a 3 here. I'd be left with w minus 2, which means that my factors are 4w plus 3 times w minus 2. And there we go. That is the factored form of 4w squared minus 5w minus 6. But notice, that was not my original function. I originally factored out that 2, so I need to show that as a factor as well. This here would be my final answer for 8w squared minus 10w minus 12. That'd be the final factored form, the fully factored form, if you will. All right. Well, that takes care of what were our Objective 4.1 notes today. Hopefully we're feeling good about what we did. If you need more practice, definitely check out those sample problems. Otherwise, get started on those practice problems. Get some factoring done. This is Mr. Carter signing off. I'll see you next time.